Okay, so let's look at page 1, this question D, and see how to find the equivalent resistance. Now, there are 3 resistors right here, okay? 60, 60, 60. First of all, you have to first find out if there's any direct relationship between any 2. You can see that this resistor and this resistor, they're in what kind of relationship? Series. So if they're in series, you simply add them up to be 120 ohms. Now, what about this circle, this part here and this part? They're in parallel. So, see, the idea about equivalent resistance is that you can replace these 2 resistors by one single resistance with 120 ohms. Technically, you can do that. So imagine you replaced these 2 by a single one with this amount, and this one will be in parallel with the 60. So remember how to add up resistance in parallel? 1 over RT equals 1 over 60 plus 1 over 120. So using your calculator with the help of the fraction button, 1 over 60 plus 1 over 120, that equals 1 over 40. As a result, the total resistance is going to be how many ohms? 40. Let's see if that's the answer. It is, okay? 40 ohms right here, 40 ohms. Okay, let's see if there are other examples. I'll look at page 2. Now the answers will be on Moodle. I'm working on the answer now, but let's look at page 3. Maybe I can do, now 5, 6, and 7 are kind of similar. So maybe I can do number 5, and then you guys can spend the class time working on 6 and 7. How's that? So I'll do number 5, okay? This is a good question. It's a good question. So first of all, imagine currents are going around the pathway from positive to negative. And how many pathways are there? There are quite a lot. So first one may be this one, path number 1, and then path number 2, and then 3, and then 4, and then 5. There are 5 different pathways. Okay, so let's draw the direction of current to show how the current goes from positive to negative. So these 3 currents are splitting, and then they join back here, and it splits again, and it joins back again, back to the battery. Now, make sure you draw the direction of current to begin with. Okay. Well, if you disagree with the number of pathways I've just indicated, don't worry. That's not the main thing of this. So draw the direction of circuit current first. And then look at what you have been given. So you see that you have the battery 120 volts given. Total current is 6 amps. And you have been given all the resistance. Well, what I do know is that if this is 6 amps right here, okay, this 6 amp is going to be the same along the same pathway. That means anywhere along this pathway, you see my red dot? Anywhere along the red dot will have the same current, 6 amps, because they are in the same path. So that means the current is going to split from this point from 6 amp into something, something, something. I don't know. 6 amps right here. It's going to split into 3 paths. What can you possibly find now by the given information? Oh, we don't know the resistance of this one. We don't know the resistance of this one. What can we find first? What can we find first? Yes? Total voltage for this?
No, for the three path. For the three path.
For the 3 paths, okay. How do you find the total voltage?
Well, no, it's already given to you. It's 120 volts.
120 volts is a total voltage, but that's not 120 volts right there. Remember, you will spend all the voltages before going back to the dry cell. That means the voltage here plus the voltage here plus the voltage here must be 120. So that one itself must not be 120. Guys, I can see that you get VT, you get IT. Tell me, what can you get from this? Let's get RT. RT will be voltage divided by current. V equals IR. 120 divided by 6. Total resistance has to be 20 ohms. Okay, 20 ohms. Now, can we possibly find the total resistance of this circle? What's the total resistance there?
Oh, you can find that and then add them up.
Yeah, and then you want to find the missing resistance here first. Okay, so the total resistance of the blue circle here, the total resistance will be 1 over 60 plus 1 over 12. And then you take the reciprocal. I know that it is exactly 10 ohms. Okay, so inside the blue circle, I combine the resistance in parallel. The total resistance for these two combined is 10 ohms. What about the 3 resistance right there? The total resistance will be 1 over 11 plus 1 over 22 plus 1 over 33. All add together, you get 1 over 6. So the total resistance for this part will be 6 ohms. So who can tell me the resistance, unknown resistance in the middle? It will be 4 ohms. Now, by knowing 4 ohms, we know that the currents going through 4 ohms has to be 6 amps, correct? Because no matter how these currents split into 3 paths, right? They split into 3 paths. Oh, see, I get 3 fingers on the iPad. So this current split into 3 paths. When they join back, I can't squeeze my finger any further. When they join back, you get 6 amps back. Make sense? So you have the current and the resistance. What can you do? Voltage equals IR. So 6 times 4. Now you know this is going to be 24 volts. This is 24 volts. Make sense? Now, what about this circle right there? What about that circle? Let's see if I'm able to. Yeah. Let's look at this circle right here. So it is 10 ohms. What is the currents going through this 10 ohms? What is the total currents going through this 10 ohms? 6 amps. But even though it is split in 2 paths, but remember, you can always imagine you replace these 2 resistors with one single resistor with 10 ohms. If you did that, there will be 6 amps going through this 10 ohms. What must be the voltage going through this part then? V equals IR. It has to be 60 volts. Because they're in parallel, 60 volts on the top, 60 volts at the bottom. Right? Top 60 volts, 60 volts, bottom 60 volts. Now you can find the current on each of those. So current on I2 will be 60 divided by 12. I know it's 5 amps. If this is 5 amp, this has to be 1 amp. And it matches the total resistance before splitting. 6 amps split into 1 and 5. It must be correct. Now what about this part here? What about this part here? What will be the voltage across each resistor? You should know that now, because think about this path. I'm looking at this path. It's 120 volts. Something is gone. And 24 volt, here is 24 volt. 24 volt is gone. And 60 volt is gone. That sums up to be 120. What must be the unknown right there in terms of voltage? Isn't that 120 minus 60 minus 24? 120 minus 60 minus 24. I got 22 volt. This has to be 22 volt because they're in parallel. All these three branches are in parallel. They must get the same voltage. 22, 22, 22. Now you have the voltage, you have the resistance. Can't you find the current? So the current for number 4, let's say, will be 22 divided by 11. You'll get 2 amps. Let me say here, 2 amps. What about,
36 volts.
oh, what did I do wrong? The voltage should be 36? Sorry. Okay. Let me write this again. So 36 volt, correct? 36 volt, 36 volt. So 36 divided by 11, you're getting 3.27 amps. 3.27 amps. What about 36 divided by 22? 1.64 amps. What about 36 divided by 33? 1.09 amps. Let's check the current. Does 3.27 plus 1.64 plus 1.09 equals to 6? Close enough. 5.99 maybe. Okay, so that must be the correct answer. And then you can fill up the rest of the answer. Let's look at page 4. See what I have. Now, for 1A, all resistance is 50 ohms each. I know, well, it didn't convert the ohms properly. So can you fill in the box with ohms? Yeah, this is 50 ohms instead of 50 square. Now, how are we going to look at these circuits? It looks weird. There's like a Christmas tree, like a triangle here, and they all join to one single point, and they go back to the battery. They're actually in parallel. Now, one of the techniques you can do with something like this is redrawing the circuit. Draw it such that the way you can recognize, and it's not changing the circuit. So the way I would like to redraw the circuit is like this. The circuit will be actually something like this indeed. This circuit and the question given is exactly the same indeed. Can you see that? You just simply, if you use your finger just to match the wire of these three connectors, just mash it up together, don't you get this? And you get this you get this circuit. But indeed, the one on the right is exactly the same as the one in the question. And I'm sure you know what to do with this one. You know what to do with this one. Easy, right? 1 over 50 plus 1 over 50 plus 1 over 50. And then you take the reciprocal. Check out 1B as well. Okay. Now, for page 5, I think this is okay. So I think these questions are pretty much straightforward, and you are able to do it. Now, let me do maybe this one here for you on G. So the question's asking you to find the equivalent resistance. The last page, equivalent resistance. So to find the equivalent resistance, this is what you do. Once again, you look at any pure relationship, whether it's a parallel or series. I can see that, well, can you see any pure relation between any two resistors? Which two?
12, 4, and 14.
Yeah, these three. 12, 4, and 14, they are in pure series relation. So you can add these three up together into how many ohms? 30 ohms. 12 plus 14 26 plus 4, 30. So the equivalent resistance will be 30. Well, look at this one in the middle. 30 and 30. What relation do they have? This square and this weird shape. Do they have any relationship together? They're in para. Good. So that means if you add up this chunk together, you're going to get 1 over r equals 1 over 30 plus 1 over 30. That gives you 1 over 15. That means this blue square has an equivalent resistance of 15 ohms. Now, do you now see any other relationship? Consider this blue one is one thing. Does it have any relationship with any other resistor? Yes, with the 5 ohms. So 15 and 5 in what relationship? Can you see? Series. This blue box and this 5 ohms are in series. So in combination, this one will be in 20 ohms in total, right? This is going to be 20 ohms. 20 and 80, what relationship do you see? Para. Good. So total resistance, 1 over RT equals to 1 over 80 plus 1 over 20. Okay? So 1 over 80 plus 1 over 20. You get 1 over 16. So total resistance, so to speak, total resistance for this question has to be 16 ohms.